All right, welcome to day 2. You got packet page 11 and 12 for homework. Today we are going to work with proofs that involve the midpoint formula. So, to review from last unit, your warm-up is to see if you can find the midpoint of those 2 points. So go ahead, pause the video, find the midpoint, and a box will pop up for you to put in your answer. So our midpoint formula, we've got x1 plus x2 over 2, our average of our x's, y1 plus y2 over 2, the average of our y's. So for us, we would have 5 plus 11 over 2, comma 7 plus negative 2 over 2. 5 plus 11, that'll give us 16 over 2. 7 plus the negative 2 will give us 5 over 2. So you could have either 8 comma 5 halves or 8 comma 2.5. Either of those answers would be fine. Moving over to the homework, all of these were using the distance formula. Step 1, plot your points, make sure your coordinates are labeled. Step 2, write out the actual distance formula. We want to show it's a parallelogram, so we're going to do the distance of all 4 sides and hopefully show that opposite sides are congruent. So you have your 4 distances there of the sides. We do have 2 sets of opposite sides that are congruent, so we can then say ABCD is a parallelogram because both pairs of opposite sides congruent implies parallelogram. So plot the points, write the formula, do your calculations, make a summary statement that tells what you found and why you know it's true. Number 2, we want to show it's a right triangle. Plot your points. Our goal here is to find the length of all the sides and then show Pythagorean theorem works. So find your 3 distances. You have them there. If you're going to do Pythagorean theorem, sometimes it's best to not simplify them. It's easier to do your Pythagorean theorem. The one with the longest has to go in your hypotenuse spot, so that's square root of 148. It did check out, so we could say triangle PQR is the right triangle since Pythagorean theorem works. And that was it. So we're going to go on page 8. So basically, it's the same steps that we did yesterday. The only difference is today we're going to work with proofs that involve the midpoint formula. So as a reminder from the warm-up, there's our midpoint formula. You can put in that first box. Really what we're doing is we're averaging our x's, adding them and dividing by 2, and then comma, then adding our y's and dividing by 2, and that gives us our midpoint. So one of the big ones that we can do with midpoint is show that diagonals bisect each other. So if we look at our points here, the furthest we need to make sure that we have some room to plot that 5, 3. And we don't go that far to the left. So I'm going to draw my y-axis there. So we got -1, -2 for A, 4, 0 for B, 5, 3 for C, and 0, 1 for D. So let's think of a plan. Back in our earlier proof units, if we had diagonals bisected each other, we then did segment bisector implied midpoint. And we said things like E is the midpoint of AC and DB. So the way to show that diagonals bisect each other is to show your 2 diagonals have the same midpoint. So second, our formula we're going to use is our midpoint formula. So we'll add our x's and divide by 2, add our y's and divide by 2, and that'll give us the point that is our midpoint. So we want to do the midpoints of our diagonals. So we're going to do the midpoint of both DB and the midpoint of AC. So for DB, we're going to take an x plus an x, so 4 plus 0, and then over 2, and then a y plus a y over 2. Well, this is going to give us 4 over 2, which is just 2, and we'll have 1 over 2, which is a half. Then for AC, we'll have negative 1 plus 5 over 2. For the y's, we'll have negative 2 plus 3 over 2. Negative 1 plus 5 is 4. 4 divided by 2 is 2. Negative 2 plus 3 is 1. 1 over 2 is a half. Notice those midpoints are the same. So our goal was to show that diagonals bisected each other, because if diagonals bisect each other, that will give us our parallelogram. So a couple steps we need to do. First we state what we know. So we were hoping to show that ABCD is a parallelogram. And then we have to say since or because. So since AD, oops, not AD, AC, sorry. Since AC and DB have the same midpoint, they bisect each other. And we know diagonals bisect each other implies parallelogram. So this is the most common midpoint proof you will see, to show that something's a parallelogram by showing the diagonals bisect each other. And we would do that by connecting showing that the diagonals have the same midpoint. All right, moving over to page 9, we're given a quadrilateral, and we want to show that if you join the midpoints of this quadrilateral, that it will create a parallelogram. So in our original quadrilateral, notice we've got to get up to a y value of 14, and our smallest y value is negative 1. So we're going to want to put our x-axis pretty low. So we have negative 2, negative 1. That's our A. 6, 6 is B. 0, 2 is C. And then D is negative 4, 14. Oh, and this was D. And you might be saying, well, that's not a parallelogram, which is true. Remember, it said the midpoints of this quadrilateral, if you connect them, they will form a parallelogram. So Let's find the midpoint of each of these. We can either start by writing our midpoint formula. X1 plus X2 over 2, comma Y1 plus Y2 over 2. So we'll start with our midpoint of AB. So I have negative 2 plus 6 over 2, comma negative 1 plus 6 over 2. Negative 2 plus 6 is 4. 4 divided by 2 is 2. Negative 1 plus 6 is 5. 5 divided by 2 is 2.5. And let's call that point E. And we'll plot all these midpoints in a second. So next we'll do midpoint for BC. So we'll have 6 plus 0 over 2, comma 6 plus 2 over 2. Six plus 0 is 6. 6 divided by 2 is 3. 6 plus 2 is 8. 8 divided by 2 is 4. So we'll call that point F. Next we'll do CD. We'll have 0 plus negative 4 over 2. 2 plus 14 over 2. 0 plus negative 4 is negative 4. Divided by 2 is negative 2. 2 plus 14 is 16. 16 divided by 2 is 8. We'll call that point G. And we'll finish off this part with midpoint of DA. So we'll have negative 2 plus negative 4 over 2. Then add your y's and divide by 2, so negative 1 plus 14 over 2. That'll be negative 6 over 2, which is negative 3, and 13 over 2, which is 6.5, and we'll call that point H. So we can plot those points now over here. Now note, when you plot them, they should be on the side that it's the midpoint of. So we've got 2.5 for point E, 3, 4 for BC, negative 2, 8. So mine, it looks like my line is a little off. Maybe that's a little better there. And negative 3, 6.5. And it looks like my freehand line might be off there as well. And I forgot to label my vertices. That's F, that's G, and this is H. Well, so we've got the figure. We still have to show that it is a parallelogram. So we're going to do it just like we did the last question. We'll do the midpoint of the diagonals. So let's do our midpoint of HF. We had already written the midpoint formula in the problem, so we don't have to rewrite it. So if we take our points H and F, we'll have 3 plus negative 3 over 2 and 4 plus 6.5 over 2. 3 plus the negative 3 is 0. 0 divided by 2 is 0. 4 plus 6.5 is 10.5. Half of that is 5.25. And we'll do the same thing for the midpoint of EG. So for EG, our x's, we have 2 and negative 2. So 2 plus negative 2 divided by 2. And for our y's, we have 2.5 and 8. So we'll have 2.5 plus 8 over 2. 2 plus negative 2 is 0. 0 divided by 2 is 0. 2.5 plus 8 gives you 10.5. Divided by 2 is 5.25. And notice we're getting the same midpoint there, which is good. So we'll say that HEFG is a parallelogram. So state what your conclusion is, and then we got to state why. So we need to either say since or because. Since HF and EG have the same midpoint, they bisect each other. And then we'll say diagonals bisect each other. Implies parallelogram. So if we flip over to page 10, our last two proofs of today are going to have some variables in the coordinates. So don't fret when you see that. You still work through with the same formulas, even if there's variables in the coordinates. So we want to prove the midpoint of the hypotenuse of the right triangle is equidistant from the vertices. So first we have to find the midpoint of that hypotenuse. That's the midpoint of BC. So we'll start off by writing our formula. Now notice we did not plot our points because when there's variables in your points, you can't really plot them, and they already essentially gave us the picture. So for point M, we would have B and C we're working with, so our x's are 0 plus 2b over 2, and our y's are 2a plus 0 over 2. Well, that gives us 2b over 2 and 2a over 2. If you divide those both by 2, you just get b comma a. So m's coordinates are BA, and now we want to show that m is equidistant from all three of those vertices. So equidistant means the same distance, so we're going to have to do the distance formula. So we'll write out our distance formula now. Under the square root, we'll have x2 minus x1 all squared, plus y2 minus y1 all squared. And maybe we'll start with AM. So AM, we'll take one of our x's, so we'll do b minus 0 all squared, plus, we'll do our y's, a minus 0 all squared. Well, b minus 0 is b, and then we square it, so we get b squared. A minus 0 is a, and then we square it, so we get a squared. Now note, a common error is people try to take a square root of each of those. If things are adding and subtracting, you cannot take individual square roots, so we could not touch that. If we had b squared times a squared, then we could take individual square roots and say that's ba. But if you're adding or subtracting under the radical, you cannot take individual square roots. All right, let's do bm next. We'll start with our x values maybe. So we'll have b minus 0 all squared plus a minus 2a all squared. Well, b minus 0 is b, and then we square it, so we get b squared. A minus 2a is negative a. If you square it, a negative times a negative is a positive, so we'll just get a squared again. And then lastly, we've got cm. So we'll start with our x's, so we'll have 2b minus b all squared, plus 0 minus a all squared. Two b minus b is b, and then we square it. 0 minus a is negative a, and then we're squaring it. So a negative a times a negative a will give us a positive a squared. Notice all of those distances are the same. So we'll say the midpoint of the hypotenuse is equidistant from the vertices since, and what did we just show? We showed that AM equals BM, which equals CM. All right, if we go down to the bottom of page 10, our last one for the video. So we're given a figure here. Notice we got variables again. So prove that the segment joining the midpoints of the two sides of the triangle is equal to 1/2 the length of the third side. So first we got to find those midpoints, which would be points D and E. So we'll start with our midpoint formula. x1 plus x2 over 2, y1 plus y2 over 2. We'll maybe do first the midpoint of AC. So we'll have 0 plus 2b over 2, 0 plus 2c over 2. That gives us 2b over 2, comma 2c over 2, which would then just give us BC. And that is going to be called point D. Next, we'll do our midpoint of CB. So we'll have 2b plus 2a over 2 for our x's. We'll have 2c plus 0 over 2 for our y's. Two b plus 2a, we can't combine those at all, so just divide them both by 2. We get b plus a. 2c plus 0 is 2c. When you divide it by 2, you just get c. And that we are calling point E. So we've got our midpoints. Now we want to show that their length is equal to 1/2 the length of the third side. So let's do our distance formula, because that shows us length. So we'll have x2 minus x1 all squared plus y2 minus y1 all squared. And we'll do our length of DE first. So let's take the b plus a minus the b all squared. And I purposely did it in that order, because if we had done the other order, we would have had to do b minus, and then remember to put the b plus a in its own parenthesis, and the negative would distribute. So doing it in this order, then we don't have to worry about distributing the negative. Plus, we'll have c minus c all squared. Well, b plus a minus b, the b's wipe out, and we just have a squared. C minus c is 0. So we just get square root of a squared, which would just be a. And then we've got to do AB, which, just as a reminder, so I don't have to scroll up, A is 0, 0, and B was 2a, comma 0. So we'll have square root of 2a minus 0 all squared plus 0 minus 0 all squared. 2a minus 0 is 2a. When you square it, 2a times 2a is 4a squared, and then the zeros go away. If you take the square root of both 4 and a squared, we get 2a. So what did we show? So we can say, therefore, half of AB is equal to DE, since AB equals 2A and DE equals A. So like we saw in yesterday's video, draw the picture, write the formula, do your calculations, and then write a summary. What is your conclusion? And then use since or because, saying why you know that's true based on things we've seen in proofs. That's it for this video. Have a great rest of your day.